So just as a comparative example, I'm going to do this one algebraically. This is the exact same example that we had when I did it with geometric. So I just want to talk about or do the comparison here. So remember that u plus v is our resultant here. So that tells me how to stack my equations. So I'm going to do u plus v, and it's going to give me my resultant vector. So I need to rewrite my u vector in the correct notation. Now I know that if this is my origin, I know that the head of my vector will be in the positive x, positive y. The v vector, though, to the head, if that's my origin up here, it's going to be positive x, negative y. So the signs are very important here when I go and do the question. So magnitude of u will be, or sorry, yeah, magnitude of u is 5 cos of the angle. So cos 15, that's along the x-axis, plus, because the y component would be positive, 5, and I'm going to think that's a 0.5, 5 sine 15j. The v vector, x component's positive, so it will be 10 cos 30. That would be I, minus, because the y component is negative, 10 sine 30j. Now we just add up our columns. And when I add my columns, and when I'm talking about the columns, I added those two together, and then I added those two together, or subtracted them in this case, and I got 13.5 I minus 3.7j. You can check that, make sure you get that with your calculator. Now I want to know magnitude of r. How big is the resultant? Well, it's just the x component squared plus y component squared. So it becomes 13.5 squared plus the negative 3.7 squared. When we calculate that, we end up with 14, which is fortunate because that's the answer we got previous in this example, or in this example previously. The angle theta is the tan inverse, again, of your y component over x. So it would be tan inverse, and here's a good point. Just enter in the positive numbers. I don't want you using the cast rule here. We already know that this is going to be positive x, which means that we are going to be heading east. And we know that this, because it's negative, a negative value, so that means it's going to head south. So remember, this one tells you east or west. This one tells you north and south, and because it's negative, we're heading south. Don't bother putting the negative in here. We just need the numeric value when you do the calculation. So I get 15 degrees, which again is fortunate. That's what we got before. And we can say, therefore, the resultant vector is 14 units. I know it's going east because the x component's positive, y component's negative, so it will be south, and that angle always goes in the middle for us. And there's our algebraic method. It matches up with previous question. Now let's do a 3-vector addition here. And I just want to remind you how much quicker it is. So, and labeling the vectors in the order they appear, u plus v minus w is equal to my resultant. So I'll do the stack notation over here. So my u vector, v vector, w vector will equal my resultant vector. I'm doing u plus v minus w, so you need to be careful with those signs. And we enter in the information here. So magnitude of u is given, so 25 cos 45i. And we'll notice that the head is both going to be positive for the u vector, so plus 25 sine 45j. Now the v vector, if this is the origin, that means that it's heading in the negative direction on the x-axis, and it doesn't really matter on the y because it's really 0. So we can simply say negative 10i and then plus 0j just as a placeholder. I don't need to worry about the angle of 0 degrees or 90 degrees because it's on the axes, so you don't, the angle will come out to be 1 or 0 depending on which one. All right, if you put the angle in, everything will still work out fine. W vector, I know the head is located in the positive x, positive y direction, so that means I would end up with 15 cos 75i plus 15 sine 75j. And again, what am I going to do? I'm going to add my i's together. I'm going to add my y's together, noting the symbols on the side. So just be careful when you're punching this through the calculator. So as I run my numbers through, this is what I came up with. My resultant is 3.8i plus 3.2j. I want to find the magnitude of my resultant. So x component squared plus y component squared. 3.8 squared plus 3.2 squared. And when you run that through, you get, let's call it 5 units. Theta then, tan inverse of your y over your x. So tan inverse of the 3.2 over 3.8. And there we go, 3.2 divided by 3.8. Shift tan, I get 40 degrees. So you can see how much quicker it is adding and subtracting 3 vectors. It really wasn't much different than doing 2. So therefore the resultant is 5 units. And again, I know that it's going to be east because that's positive, and I know it's going to be north because that's positive. So I put my east and my north in, angle goes in between, there's my 40 degrees. All right, same as it is for 2 vectors, you just have a third vector in your stacked equations. All right, and you handle it accordingly. So now I have a word problem here, and really the only challenge with the word problem is to simply be able to draw the picture. So, drawing my directional crosshair, you walk 20 meters north, 25 west. So that's 20 meters. North, 25 west. If you remember from grade 11, we don't want that angle. We actually want the angle with the x-axis. So we want 65 degrees. 80 meters east, 20 degrees south. So east, 20 degrees south. So here's the second vector. That angle's fine. I don't mind that one. And then we do a third direction here, 50 meters south, 35 east. So it's in here. It's an angle I don't want. So you take the 35 away, we get 55. And I gotta be careful I don't get them mixed up. So determine your displacement and your velocity. So I'm going to be combining a couple things back from grade 10 here. So displacement, again, will be first vector plus second plus third is going to give us, or will represent, our resultant is equal to the resultant vector. So that means I can just go ahead and stack my vectors. I just got to be careful of the resulting signs here. So the u vector, it's going to be a negative x component, 20 cos 65, so that's my I component, and y component is positive, plus 20 sine 65j. The v vector, the second one we did, was 80, and it's positive x direction, so 80 cos 20i, and negative, because the y component is negative, 80 sine 20j. So also remember when I drew that picture there, I made sure all my vectors have their tails at the origin. When you're using that algebraic method, very important that all of your tails are set at the origin because we need to use the angle the vector makes with the x-axis, so therefore they'll have to be drawn accordingly. So 55j. So there is the setup for this question. Now we just need to add the columns, and again I'm going to emphasize with the highlighter here, just because it's cool and I have a highlighter. But I'm just going to add those boxes together. I'm adding my I component, adding my J component. So I get 95.4I minus 50.2J. Magnitude of my resultant will equal 95.4 squared plus the negative 50.2 squared. Remember, when you square a negative number, it always ends up being positive. So we'll make sure with the calculator, I never actually use the negative in there, so I don't have to worry about it. but you get a resultant of 107.8 meters. So that's how far you traveled from your starting point. And that's all that's really measuring, is how far have you gone from your starting point. All right. Now, what direction did you go from the starting point? Well, it's your tan inverse of your y over your x. Again, don't worry about the sign. You just entered it as positive because we already know the direction. I don't need the angle to tell me that. I already know it because of the sign related to your x and y components. So 27.8 degrees. So therefore, my resultant here, oops, is, so I actually am 107.8 meters from where I started. My direction, this is positive, this is negative, so that means east and south. So east and south, and it would be 27.8 degrees. All right. So basically what we did was we took our three vectors. The u vector is heading in this direction, then the other vector, and then the other vector, and our resultant ended up being down here. So we did that in this process right here. So that's what it would have looked like. That's how you would have walked. So if I'm sending you on a treasure hunt, you ended up only being 107 meters from where you started, even though you traveled all that distance. Okay? And that angle is right there. So I know I have on the printout one more example. The only difference, exact same question. Actually, we got to finish that previous one. It wants a velocity as well. Sorry, let's finish that off then. So velocity, remember, is your displacement over time. So it would be the magnitude of the resultant over your time. So if I take the 107.8 and I'm going to divide it by, I thought it was 10 minutes. Was it not? It was 10 minutes. Then we get 10.78 meters per minute. So therefore, our velocity is 10.78 meters per second. And your velocity is always in the same direction as your displacement. So it's the same as the resultant. Your acceleration is always in the same direction as your velocity or your resultant for these when you're adding and subtracting vectors here. So there are the two answers that the question was looking for. Our resultant, or our displacement, and our velocity. So those are the two answers that they were looking for. So this final one, like I said, it's pretty much the same idea. The difference is you're looking for the resultant is given, and you're looking for that third movement. So just to give you a quick, we always set it up like this. The three vectors, u plus v plus w, is going to be the resultant. This question says, determine the third movement. So we are looking for w. So what we're going to do then, and we did this in the grade 11 course as well, we subtract u and v from both sides. So it would be the third vector is equal to our resultant minus the first vector minus the second vector. And you just set it up accordingly. So you would set it up r equals minus u equals minus v equals, and that will give you your w vector. All right. So you can finish that off. I don't want to take up any more of your time, especially for the people that know what they're doing or feel comfortable with the vectors. There's the assigned homework. Probably will take you 2 days to get through that in class, just because of the magnitude of the lesson and the importance. So it is so important that you do feel comfortable with vectors. You have to feel comfortable with them because we will be using them extensively throughout. So I can't emphasize and stress this enough. Let's get to a point where you're very comfortable with those vectors. So if you have any questions, make sure you do ask in class. Thank you. We'll see you tomorrow, and see you in the next video.